Bond polarity. Polarity in a compound is the ability of an atom to attract electrons present in other compounds. In a periodic table, the electronegative values increase from left to right and from bottom to top. The degree to which the bond is ionic is determined by calculating the difference in electronegativity between two atoms. If the electronegative charge between atoms is large, then the bond between the two atoms is ionic. Generally, an ionic charge greater than 1.7 results in a bond that is ionic. A bond less than 1.7 is covalent. There are two types of covalent bonds, polar and nonpolar. In a nonpolar covalent bond, the bonding electrons are shared equally between the two atoms. The electrical charge is equally distributed between the two atoms. Diatomic elements are always joined by covalent bonds. There are 7 diatomic elements whose natural form is a diatomic molecule. They are hydrogen, H2, nitrogen, N2, oxygen, O2, fluorine, F2, chlorine, Cl2, bromine, Br2, and iodine, I2. Molecules with minor differences in electronegativity are also considered nonpolar covalent. A bond with electronegativity difference between 0.4 and 1.7 is called a polar covalent bond. The distribution of electrons in polar covalent bonds is not symmetrical. Hydrogen fluoride is ionic as it has an electronegativity difference of 1.9. The electron density around the fluoride atom is greater than the electron density of the hydrogen atom. The electron density is represented by the Greek letter delta. The atom with greater electronegativity acquires a partial negative charge, while the atom with lesser electronegativity acquires a partial positive charge. A polar molecule is one in which one end is slightly positive and the other end is slightly negative. A diatomic molecule that has a polar covalent bond is a polar molecule. A molecule with two poles is a dipole. HF. Hydrogen fluoride is a dipole. For molecules with more than two atoms, the molecular geometry must also be taken into account when determining the polarity. Carbon dioxide is a linear molecule. The oxygen atoms are more electronegative than the carbon atoms. The two dipoles are pointing outward from the carbon to the oxygen atom. Since the dipoles are of equal strength, they cancel each other out and the molecular polarity of CO2 is 0. In a water molecule, the dipoles do not cancel each other and so it is polar. Below is the bent nature of the water molecule due to the difference in electronegativity. Other forces between molecules. 1. Intermolecular forces, attractions and bonding that occur between molecules. These are weaker than ionic or covalent bonds. These forces are important as they cause physical state changes in molecules such as melting and boiling point changes. 2. London dispersion forces. These occur in atoms and molecules due to the random motion of electrons. These are the weakest. 3. Dipole-dipole forces. These are attractive forces that occur between polar molecules. 4. Hydrogen bonding. It is an intermolecular attractive force in which a hydrogen atom, that is covalently bonded to a small, highly electronegative atom, is attracted to a lone pair of electrons on an atom in a neighboring molecule. These are strong compared to dipole-dipole bonds but weaker than covalent bonds.